Welcome back, everybody. This is section 3.4. It's graphs of polynomial functions. And before we even begin, there's a caveat. You all have technology, calculators. If there's ever a question about graphing, put it on your calculator. But this is, graphs of polynomial functions. And so we're going to talk about some properties. Recall polynomial functions. Just recall. Polynomial function, x, the n, that's the leading, the degree is n, that's the leading coefficient, n minus 1, plus a sub 2, x squared, etc. That's a polynomial function. And they look like this. Whoa, there's bumps and ups and downs, max and mins. This would be actually a third degree polynomial. This is degree 3. And it's degree 3, and there's 3 solutions here. That's what it's all. That's what this the rest of this chapter is all about. Trying to find these things. And here's like a fifth degree polynomial, where there's 4 bumps. But what we are going to be interested in the rest of this chapter is trying to find those. And of course, there's so many techniques. The first one is factoring. Because suppose you have a polynomial, x cubed minus 5x squared minus x minus x cubed minus 5x squared, 5x plus, I'm sorry about that. I think I screwed up. Minus x plus 5. Oh, sorry about that. Yeah, just like so. Suppose you have a polynomial like that, and you want to find the zeros. First off, this thing looks, it's going to start way down here. It looks something like that. You want to find those 3 zeros. So, and here we can factor, because these two have an x squared. And this, if I take out a negative 1, it would look like that. That's factoring. X minus 5, whoops. And what we want to do with the whole point is we're setting this equal to 0. And if it's in factored form, well, we're going to let x minus 5 equal 0. And then we're going to let x squared minus 1 equal 0. X is plus and minus 1. So those are the 3. I just drew this out. So those would be the 3 zeros for that one, if it's in factored form. And it's nice when it's in factored form. The rest of this chapter is dedicated to trying to solve for these zeros. And there's several techniques, most of which involve factoring. Factor. But, okay, erase this board, and on we go. And if it's already in factored form, let's start there. For example, f of x equals, let's say, 2x minus 1, x minus 3. So far, this is degree 2. There will be at most 2 solutions. 2 solutions, and the 2 solutions are x is a half and x is 3. 2 solutions. Well, let's go. 2x, I'll put 3x plus 7, x minus 2, 5, x plus 3. And now the degree here is 3. By the way, the leading coefficient is also 3. Well, we'll talk about it as we go. But the zeros are x is negative 7/3 from here, x is 2 from there, and x is negative 3 from there. And so, if it's in factored form. Now, let's bring this one up. Got my dog's Zeta. Yeah. Hi, too. My cat. I don't know. Let's bring up something such as in factored form. And again, the rest of this chapter is trying to get things into factored form. Something like this. X minus 2, say, and x plus 3. One of these I'm going to raise to a power. Well, we'll raise the last one to a pattern. 2x minus 3 squared. Okay. First, the degree of this polynomial is, there's an x, and you're going to multiply by that, so that's x squared, and then you're going to multiply by another x, and you're going to square that, so there's 2, 3, 4. Degree, it's a fourth degree polynomial, it's an even polynomial, and you'd like to know that. So it has at most 4 solutions. However, this one is twice. So x is 2, x is negative 3, and then x is 3/2 twice. Because there's 2 of them. And the graph depends on that. There's something called, well, this is called a multiplicity 2. X equals 3/2, x equals 3/2 of multiplicity 2. Because it occurs twice. Now, the behavior of a graph at that, when the multiplicity happens, the behavior of the graph does certain things. In this case, it's multiplicity 2 of 2. It would just hit it and go back up once. Okay, so that's multiplicity. And then, I'm just going to mention the end behavior of these things again. Oops. Polynomial functions. And if you recall from the last video, the end behavior, as x gets really, really tiny, it goes towards negative infinity, the things that happen if it's even, if it's odd, and the leading coefficient, it's the same thing. Depends upon leading coefficient and degree. And degree. And I don't think I'm not going to take any more time in this video to talk about that, because go back to the last video. We talked quite a bit about end behavior. Now here's the one thing that's from this particular section that is extremely important. It's called the intermediate value theorem. And we extend this theorem. But for us right now, there's something called intermediate value theorem. And we're looking for zeros. So we're actually, this intermediate value theorem, we're going to make this very specific to looking for zeros. And all we're saying is if A and B are real numbers, if they're numbers somewhere on the number line, and they're different, so A is less than B, and if f at A is less than, is less than 0, and f at B is greater than 0, all we're saying is there has to be a number between them. Then there is a number, by the way, there exists, look like that, a number C, which is also a real number, between A and B, such that f at C is zippo. Here, it's a lot easier to picture, but this is a really important theorem, and actually it wouldn't have to be, it's a really important theorem in terms of where you're headed. All we're saying, here's a polynomial function, something like that, I don't know. Here's A, f at A, greater than 0. Here's B, f at B, less than 0. Then there has to be a number between those two. Between A and B, that f at C equals 0. It's the intermediate value theorem. Just an example of it. Suppose, let's see. F at x is x squared plus 3x minus 2. Now you can factor this, you can do all the stuff, but I just want to use the intermediate value theorem by noting f at 0, the function's value at 0 is -2. And the function's value at 1 is 1, 4 is 2. Because this is negative and this is positive, there must be a number. There's a c inside of 0, 1, such that f at c equals 0. X squared minus x squared. Okay, so then that's it. There must be a c in there. Thank you. Next time.